In this problem, we are told to solve for matrix A if we have B equaling this particular matrix and AB equaling the other matrix given to you. So all the work is shown for this problem. I'm just going to walk you through the work and explain to you the process for finding the answer. So here, the first step is we know A times B equals the matrix given to you 1, 2, 3, and 1. So here we have A times B, which was given to you, equals, and we're told that that's going to equal this matrix right here. Now to find A, kind of the same idea as with any equation, I need to do the inverse in order to get A by itself. So same idea, I need to take the inverse of this matrix over here to get rid of it, and so that will give us A on the left side by itself, and then when we find the inverse of it, it's going to bring it over here to this side on the right. And it does matter where you put it, it will be on the right side over here. So now what I need to do is find the inverse of this matrix right here. So to find the inverse, I need to first find the determinant of that matrix. So to do that, I'm going to multiply across. The 1 times 3 is going to give me 3, and then 2 times negative 1 will give me negative 2, and then I subtract those two numbers. So right here we see the 3 minus the negative 2 down here in this fraction, so that's going to give us a 5. And so when you're finding the inverse, we take 1 over that determinant of 3 minus a negative 2, and then we multiply it by a different matrix that we can get by looking at this original one here. So we're going to flip the 1 and the 3, so we're going to get a 3 up here and then a 1 here. We just switch the location. Then we're going to change this 2 and this negative 1 to be the opposite. So positive 2 will now become a negative 2. Negative 1 will become a positive 1. So what we have is we have 1 over 5 times, it's going to be 3, negative 2, 1, and 1. So this is what we have now. We have 1/5 times all of this. The 1/5 we can bring out as a scalar, so it doesn't matter the order in which we multiply that. But the two matrices here, it does matter the order. So first I'm going to multiply the matrices together, and then we'll get our fractions in later. It'll make things a little easier doing it in that order. So when I multiply matrices, I take row 1 times column 1, so I take 1 times 3 gives me 3, plus 2 times the 1 gives me 2, so 3 plus 2 gives me 5. That's going to go right here in the top left corner. So then we take row 1 times column 2, and we get 1 times negative 2 gives me negative 2, plus 2 times 1 gives me 2. So negative 2 plus 2 gives me a 0. That's going to go here in row 1, column 2, because we took row 1, multiply it by column 2. Now to find this number, the 10, we take row 2 times column 1, we take 3 times 3 gives me 9, plus 1 times 1 gives me 1, so we have 9 plus 1 is 10. It's going to go here, row 2, column 1, because we're taking row 2 times column 1. And now row 2 times column 2 will give me this number here in row 2, column 2. So we take 3 times negative 2 gives me negative 6, plus 1 times 1 gives me 1. So negative 6 plus 1 gives me negative 5, and that goes there. So we have 1/5 times this new matrix. So since we have a scalar out front, we take the 1/5 times every part of the matrix. So 1/5 times 5 gives me the 1, 1/5 times 0 gives me 0, 1/5 times 10 gives me a 2, and 1/5 times negative 5 gives me a negative 1. So this matrix here, 1, 0, 2, negative 1, is my final answer.